Hello, this is Calculus AB, AP Calculus AB, A, Unit 3, Lesson 1. I know that's a lot of letters. Unit 3, Lesson 1, an overview of limits is the topic. And so we're just going to, as by way of introducing the concept, we're going to just consider an object under gravity falling, right? So let's take a tennis ball or an apple or something, and let's drop it. Let's drop it from a height well, let's just drop it from a point we'll call 0, and we'll go down our scale. So this will be 1 foot, 2 feet, 3 feet, 4 feet, 5 feet. We're not going to consider where the ground is right now. 7 feet, 8 feet, 9 feet. Okay. And so on and so forth, going down, right? And we're going to drop the object, drop the ball, and it's going to accelerate in the downward direction by the acceleration of gravity, which is 9.8 meters per second, or 32 feet per second. 32 feet per second. Okay, and I think the lesson focuses mostly on the 9.8, but we're going to use 32 just to be a little different. Right, and what happens basically is what happens is initially the speed of the ball is 0 when it starts, right? But after 1 second, the ball will be traveling 32 feet per second. After 2 seconds, the ball will be traveling 64 feet per second. After 3 seconds, the ball will be traveling 96 feet per second, and so on, constantly gaining another 32 feet per second every second. So actually, meters per second squared. Meters per second squared. So it's meters per second, or feet per second. Okay, feet per second squared. That's acceleration. And that is constantly changing. So let's say we'll make a table here of values, right? So t and d for distance, all right? Initially, the ball has traveled 0 feet, or at time 0, the ball has traveled 0 feet, right? Okay. The motion of the ball can be modeled by this formula: d of t equals, and usually it's negative because down is negative, but since we're considering down as positive, we'll do positive. The acceleration of gravity divided by time. All right, divided by 2. Acceleration of gravity divided by 2. And later on, we're going to learn where this formula comes from. Acceleration of gravity divided by 2 times time. Or d of t is the acceleration of gravity 32 divided by 2 times time. Or d of t is 16t. And that's where that formula comes from. Okay, the acceleration of gravity divided by 2. Time squared. Boy, leaving off all kinds of details. So that means that time 1, at 1 second, the ball will travel 1 squared, or 1 times 16 feet. At 2 seconds, the ball will travel 2 squared, or 4 times 16, 40. 4 times 16 is 64. Okay. At 3 seconds, 3 times 3 is 9. 9 times 16 is 90, and 54, 144 feet. Okay, and so these we can fill in this table and find out where the ball is at any given moment, right? And I can even use my graphing calculator to graph those points, right? I can do a table, or I can do a set of points here, but I'm going to do a table. And so 0, 1, 2, 3, and we're going to put in 0, 16, 64, and 144. And one cool thing about Desmos is I can change my window to fit. And lo and behold, it's falling up because positive points up on the graph. But you'll notice there's kind of a curve going through this, right? At any given moment, the ball exists in between these points as well. So this is a continuous situation, but we have a discrete graph. Okay. Now there's two calculations you're going to want to be able to find. You're going to want to be able to calculate the average speed or average velocity. Velocity is just speed with direction, average speed. And you want to calculate the instantaneous speed. Okay? The instantaneous speed. The average speed and the instantaneous speed. So let's just sketch this graph again here, and I'm going to take a picture of it. Okay. Yeah, take a picture of that. All right, here we go. And let's paste that here so we can draw on it. Okay. Our average speed. So let's say we want to find the average speed between the first and the third second, right? The average speed. So answering the question, what is the average speed or velocity from 0, not 0 seconds, I'm not going to go from 0 seconds, from 1 second to 3 seconds. Okay, and here's how we do that. We take the position it is at 1 second and the position it is at 3 seconds, and we find the rate of change between those 2 points. Okay, so we're going to find the rate of change between those 2 points. Right here, right now. Okay. So note that we're drawing a straight line because we're interested in the rate of change or the slope between these 2 points. That's an average rate of change. Slope between 2 points gives you the average rate of change. Okay. Now this point here is 144. This point here is 1, 16. So the width from 1 to 3 is 2. And the height is 144 minus 16, or 128. So the average rate of change, then here's the formula for the average rate of change, the average speed. It's v, or distance, position distance at 3 minus the displacement at 1 divided by 3 minus 1, right? Or we can call it, here's the formula in more general detail, T2 minus d of T1 divided by T2 minus T1. Okay? So more specifically, it is 144 minus 16 over 3 minus 1 for 128 divided by 2, or 64 feet per second. Okay? So the average rate of change, the average speed between seconds 1 and 3 is 64 feet per second. Now, as you can see, this shape is not a smooth, a linear shape. It's a curve. It's actually parabolic. Okay, so it's got this curve to it. And if I want to find the instantaneous speed, I've got a little bit of a more difficult problem to do. Okay, let's say I want to find the instantaneous speed. What is the instantaneous speed at 1 second? Let me clear some space here. Instantaneous speed at 1 second. Okay, and let's merge layers. Okay. Instantaneous speed at 1 second. Okay. So instantaneous speed at t equals 1, right? So here's what I'm going to do. I'm going to consider 1, right, as our time, but I'm going to add 1 plus some amount we're going to call h, right? 1 plus h. 1 plus h. We're going to add h to 1, and we're going to add, so we're going to get 1 plus h as this point, right? And then I'm going to plug that into my formula, and I'm going to get f of 1 plus h. So f of 1 plus h, right? And this is 1, and this is going to be f of 1. Okay? F of 1, of course, is 16, right? F of 1 plus h, I don't know. But remember our formula. Our formula is d of t equals 16t squared, right? 16t squared. So let's use this formula. So the rate of change, or the speed, or the velocity, is the change in y, so d of 1 plus h minus d of 1 divided by 1 plus h minus 1. Okay? And let's plug that in to our formula. Let's do a little substitution. So our speed is d of 1 plus h, so 16 times 1 plus h squared minus 16. Now you can do 16 times 1 squared if you like. All over, notice the 1's cancel out, leaving just h. So a little algebra now. I hate it when my professor would say, and the rest is algebra, and he would leave it for us to do. So 1 squared is 1 plus 1 times h times 2 is 2h plus h squared minus 16 squared is, or 16 times 1 squared is 16 all over h. Okay? Distribute or factor, actually. Factor out 16. I think that's even a better step. 16 times 1 plus 2h plus h squared minus 1 all over h, and the 1's cancel, which is really important. So we get 16 times 2h plus h squared over h. And now notice, I'm going to make a little room over here. Well, actually, let's do this here. Let's just shrink-a-dink, okay? Because we're going to run out of room if we don't, okay? So now, factor an h out and cancel it with the h in the bottom. 16h times 2 plus h divided by h. The h's cancel, leaving 16 times 2 plus h. Okay? Now consider what happens as h gets really small, and that's really the big idea of calculus here. What happens as h gets really small, or what we're going to learn of this is it's a limit as h goes to 0, right? It gets closer and closer and closer to 0. It doesn't actually reach 0 because you can't find the slope between 2 points if the 2 points are exactly the same. But we're going to take the slope as h gets really, 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 really tiny, all right? And in reality, in this case, I can substitute 0 for h. 2 plus something really, 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 really tiny, right, is 16 plus times 2 and a little tiny bit more. So it's going to be 32 and a little bit more, but as h goes to 0, it's going to get closer and closer and closer to 32. So the instantaneous speed of the object, of the tennis ball perhaps, at 1 second is 32 feet per second. Right? And that actually matches what we talked about, right? The acceleration of gravity is 32 feet per second. So at the end of the first second, it should be traveling 32 feet per second. So the mathematics works out. So that's kind of an introduction to this lesson.